Imagine you're outside one day and suddenly it feels like the world's been plunged into darkness. You look up to see an ash cloud covering the sun. And this is no passing phase. This is just the beginning of a volcanic winter that will last for years. You might think that this scenario belongs in a post-apocalyptic movie, but scientists say it could happen to us. And it would be one of the most devastating events in human history. So what exactly is a volcanic winter, and how likely are we to experience one? Let's take a deep dive into the science. To understand volcanic winter, let's start with the opposite. Summers can be hot and steamy, but did you know that some winters are downright chilly? That's right. The Earth has experienced 4 natural ice ages. These periods of extreme cold occur when ice sheets form over the planet's poles and spread outward, covering more than 40 million square miles or 100 million square kilometers of land. But these ice ages aren't caused by volcanic activity. They happen because of changes in the Earth's orbit around the Sun, which affect the amount of sunlight that reaches the planet. Every 27,000 years, our planet's orbit takes it closer to the Sun during winter. For about 65,000 years, the Earth has had a slightly elliptical orbit that causes the northern hemisphere to tilt away from the Sun during winter. And when that happens, we get less heat. And during the last ice age, which began about 115,000 years ago, the Earth was at its farthest point from the Sun. But today, the Earth is closer to the Sun than it has been in thousands of years. Scientists predict that the next ice age should begin between 500 and 1,000 years from now. But not everyone agrees that this will happen. Some experts say that the Earth won't enter another ice age for at least 50,000 years. So what does all this have to do with volcanoes? While they don't create ice ages, they can cause volcanic winters, which are similar to ice ages, except instead of being caused by changes in the Earth's orbit, they're triggered by volcanic eruptions. Volcanic winters can happen when large amounts of sulfur dioxide gas are released into the atmosphere. Sulfur dioxide reacts with water vapor, dust, and other substances to form sulfuric acid aerosols. These aerosols then reflect sunlight back into space and cool the Earth's surface. Mount Pinatubo in the Philippines erupted in 1991 and sent about 2 billion gallons or 7.8 billion liters of sulfur dioxide into the air. After the eruption, the Earth's average temperature dropped by about 2 degrees Fahrenheit or 1.2 degrees Celsius. Mount Krakatau in Indonesia erupted in 1883 and unleashed about 200 billion gallons or 760 billion liters of sulfur dioxide, causing temperatures to drop by 1.8 degrees Fahrenheit or 1 degree Celsius. Both of these eruptions were classified as 6 out of 8 on the Volcanic Explosivity Index, or VEI, which measures the relative violence of volcanic eruptions. To put this in perspective, Mount St. Helens in Washington state erupted in 1980 with a VEI of 5, while the 1991 Mount Pinatubo eruption had a VEI of 6. The largest eruption in recorded history was that of Nova Rupta in Alaska in 1912, which had a VEI of 6. But Pinatubo and Krakatau were still relatively small compared to some ancient eruptions. There's evidence that an eruption about 74,000 years ago in what is now the Indonesian island of Sumatra unleashed 1.6 trillion gallons, or 6.1 trillion liters of sulfur dioxide. Another eruption 54,000 years ago in what is now the La Garita caldera in Colorado unleashed an estimated 35 trillion gallons, or 135 trillion liters. And one eruption 28,000 years ago in what is now the Taupo volcanic zone in New Zealand unleashed an estimated 65 trillion gallons, or 246 trillion liters of sulfur dioxide. All 3 eruptions had VEIs of 7. So how much sulfur dioxide would it take to trigger a volcanic winter? Research suggests that the threshold is around 160 billion gallons or 610 billion liters. So the eruption in Sumatra and the one in Taupo would have caused volcanic winters. But here's where things get complicated. There's a difference between short-term cooling and long-term cooling. When an eruption releases enough sulfur dioxide to reach the threshold, it can cause temperatures to drop by 3 to 7 degrees Fahrenheit or 2 to 4 degrees Celsius within 2 years. But these effects typically wear off after a few years as the aerosols escape into the stratosphere and break down. However, if the eruption releases between 400 billion and 1 trillion gallons, or 5 trillion and 3.8 trillion liters of sulfur dioxide, temperatures can drop by 18 degrees Fahrenheit or 10 degrees Celsius and stay that way for several decades. If the eruption releases more than 1.25 trillion gallons or 4.75 trillion liters of sulfur dioxide, temperatures can drop by 27 degrees Fahrenheit or 15 degrees Celsius and remain low for several centuries. So if you were hoping that the New Zealand eruption would usher in an ice age, unfortunately, it probably wouldn't have done the trick. And speaking of tricks, Mother Nature has a few up her sleeve. One of them is the Pacific Decadal Oscillation, or PDO. Every 20 to 30 years, the waters of the North Pacific Ocean go through a major shift in temperature. During warmer phases, the western coast of North America experiences warmer and drier weather. During cooler phases, the western coast of North America experiences colder and wetter weather. The PDO is thought to be caused by changes in wind patterns, which in turn are caused by shifts in sea surface temperatures in the tropical Pacific Ocean, aka El Niño and La Niña. El Niño is a band of warm ocean water that disrupts the normal weather pattern along the western coast of the Americas every 2 to 7 years. La Niña is the opposite of El Niño. It's a band of cold ocean water that disrupts the normal weather pattern along the western coast of the Americas. The warm phase of the PDO and El Niño typically occur at the same time, while the cooler phase of the PDO and La Niña also tend to happen at the same time. This means that there can be multiple layers of warming or cooling depending on what's happening with the PDO and ENSO. For example, the current warm phase of the PDO may be helping to counteract some of the cooling effects of the ongoing La Niña. In addition, volcanic activity in different parts of the world may have different regional effects. For instance, an eruption in Indonesia may have a greater cooling effect on Australia than on the rest of the world. So even if a supervolcano erupted tomorrow and managed to release enough sulfur dioxide to cause a volcanic winter, it probably wouldn't be as dramatic as what we see in the movies. Instead, we would likely see a few years of below-average temperatures followed by a return to normal. But just because a volcanic winter wouldn't be catastrophic doesn't mean it wouldn't be inconvenient. Colder temperatures would slow economic growth, disrupt food supplies, and lead to energy insecurity. The cold weather alone could cause hundreds of thousands of deaths each year. In other words, a volcanic winter would suck. But there's one other big problem. We don't really know how to stop it. Since we can't control volcanic activity, our only option would be to try and counteract the cooling effects of a volcanic winter by increasing the amount of heat in the atmosphere. There are a few ways to do this, but none of them are very efficient. We could burn fossil fuels, but this would also increase the amount of carbon dioxide and other greenhouse gases in the atmosphere, leading to global warming. Global dimming is another option. This involves injecting sulfate aerosols into the lower stratosphere to reflect sunlight back into space and warm the Earth's surface. But global dimming would have unintended consequences, such as disrupting rainfall patterns and harming plant growth. Then there's solar radiation management, or SRM, in which we inject aerosols into the upper stratosphere to reflect sunlight back into space. Like global dimming, SRM could have negative consequences, such as damaging the ozone layer. None of these options are very appealing, especially since we'd be dealing with the fallout of a volcanic winter for decades. The good news is that there's no immediate threat of a volcanic winter. Scientists monitor volcanoes closely, and there are no signs that any supervolcanoes are about to erupt. Plus, most of the largest volcanoes are located in remote areas with little infrastructure nearby. Even if one of them were to erupt, it probably wouldn't cause widespread damage. So sit back, relax, and enjoy the sunshine. Just make sure to protect yourself from skin cancer. Speaking of enjoying the sunshine, thanks for watching this episode. If you enjoyed it, be be sure to check out our other videos. And if you want to help us make even more videos, you can support us. But that's all I've got, so I'll see you guys next time.